Hi, welcome to the Semantics lecture about functions as arguments. Lambda calculus has proven very useful for us in turning our functions into something that we can manage and compose with other things. And it relies on taking arguments and plugging them in. And so far we've taken arguments of simple types and plugged them into our functions, which are characteristic functions of various sets. Right. So let's take this one, right? The function cat of x or lambda x cat of x. We plug in, let's say, Bill. Right? Bill is of type E, so we plug it in here, replace every instance of x with Bill. And what do we get? We get cat of Bill. Straightforward. And so this is of type T. It's because it stands for 1 if Bill is a cat and 0 if Bill isn't. So this is of type T. And because it takes something of type E as its input, we can say that the expression lambda x cat of x is a function of type ET. Now, this takes a simple type as its argument, but we can have something that takes a more complex type as its argument. So take, for example, this expression, lambda f in d sub et, f of Bill. Now, we can't plug in Bill here, even if we didn't already have it, simply because Bill is of type E and we need something of type ET. Well, what is something of type ET? Well, cat. Cat is of type ET, but we can't just put cat, because cat, that's just the word cat. It doesn't mean anything. What we need is the expression lambda x in d sub e cat of x. We need the meaning of cat. So how do we plug this in? Well, we use the same mechanism. We look at the leftmost lambda expression, f. What's its variable? F. And we plug it in, we take the argument, and we replace every instance of f with the argument. And then we get rid of the lambda expression. So we take f and we replace it with lambda x in d sub e cat of x. Right, that's our f. And then we still keep the rest, so we keep Bill over here. All right, and that's it. That's all we have to do. Now, of course, we could stop there. That would be the easy thing. But notice how we've set up another lambda expression with its argument. So we can beta reduce this as well by doing the same mechanism we did before. Replace every instance of x with Bill. And then we get cat applied to Bill. Now, as it turns out, this is of type T as well, because it's 1 if Bill's a cat and 0 if it's not. So when we look at the type of this entire expression, this is of type T, and this is of type ET. So now we can define this expression as a function of type ETT. I would say it's of type ETT. And so that is to say, it takes a function of type ET, gives you something of type T. And notice how the result of these two processes is exactly the same. They're both sentence Bill is a cat, basically. And we got there in two different ways. So as long as we have the right domain for the function, we can build it either by plugging in the cat, if we're missing cat, or by plugging in Bill, if we're missing Bill. And now it does raise the question, right? Well, what if this is what Bill means? Right? Which is like, wait, what? Well, if cat can take Bill as its argument, because it's a sister, well, by functional application, nothing prevents us from going the other direction and saying that this is what Bill means, and then we're just plugging cat into it. Right? That is to say, this would be what Bill means. What is that? Well, this would be the set of properties that Bill has. And in essence, well, that is kind of what Bill is, right? You think about the difference between you and the next person and the person next to you, right? What is the difference? Well, you have different properties. You have a set of properties, they have a set of properties. Everyone has their own set of properties. You know, we're all unique snowflakes and that sort of thing. So you could define a person essentially by the kinds of properties they have. And so, in a sense, there's not really much of a distinction between the set of properties that Bill has and Bill, because they will both get you Bill. Now, what does that mean for syntax? Well, it basically means that we'll have to determine what the meaning of, say, cat is and what the meaning of Bill is based on the way that the syntax combines with the semantics. Because the semantics can go either way, it doesn't really care. Right? Functional application will get you the right result, depending on which way you go. So it's always something that we have to keep in mind. We have to keep in mind what Bill and cat are as far as the syntax goes and how they correspond to the rest of the sentence. That's something that we'll be watching out for throughout the semester.